Hello and welcome to session 284 in the AIsafety.com reading group. Tonight we will be discussing the first part of the article, Imitation Learning is Probably Existentially Safe, by Michael Cohen and Marcus Hutter. Michael Cohen is a postdoc with Stuart Russell at the University of California, Berkeley, and Marcus Hutter is a senior researcher at Google DeepMind. We've talked quite a bit about Marcus Hutter. Previously, he's the inventor of the IXI model of computation. We will, in this video, be discussing chapter 1, 2, 6, and 5. And probably next time we will discuss chapter 3, 4, and 7. And the reason for this is that I feel that chapter 2 and 6 are very strongly related to the extent that the authors should probably have merged them or at least put them next to each other. There is also some relationship between chapter 3 and 4, but we'll talk about that next time. This paper was probably originated by the Open Philanthropy Worldview Contest, where Open Philanthropy made a general call for posts or papers that could update them on two claims. The first is the probability that we'll have transformative artificial general intelligence by 2043, and the second, the probability that we would have an existential catastrophe given the fact that we have transformative AGI before 2070. And this isn't like that strongly related to this, but I think it is. I think it is still a very good paper, and in particular, the thing I like very much about this is that this is a paper that is actually using the inside view. So we're looking at, okay, what are the arguments that we'll have transformative AGI, and in particular, what are the arguments that this will be an existential catastrophe? And I think it's really strange and sad that so many people don't do that, because I think in order to refute the arguments for AI doom, you really need to read them. And in general, in this worldview contest, people totally did not do that. The other entries were things like people running a persuasion tournament, people trying to see if the efficient market hypothesis were like evidence in favor of this, or like could you look at evolution and see whether that provides some kind of evidence in an outside view kind of view. This may be somewhat closer to the inside view in the sense that people arguing for AI safety has been using this analogy, but it's not really load-bearing or very important, or haven't been used much for the past 15 years. Another thing, another of the winning papers, there were many papers, these are the winning papers, and Michael Cohen, I think, got a decent placement among the winners. And by default, arguments for deception and reference class based priors, that's like purely outside view, and parameter forecast, uncertainty in AI forecasting. So Michael Cohen is the only one who's actually looking at the arguments, and I'm really happy. I should state here that I have only briefly skimmed the others, and it is in fact certainly possible that some of these people have deep inside the documents made some reference to actual arguments. So I may be very unfair. Let's talk about imitation learning, and I think imitation learning is often contrasted with reinforcement learning. Here you can see a very classic example of an agent taking actions in the environment, get some observations and rewards and things like that back, and that's like standard reinforcement learning as we know it and love it. Imitation learning is a variation on this, where we introduce an expert, a human expert, and then both the agent can query the expert and get some feedback, and when the agent takes action, you can also see what the expert would have done in that particular scenario, and that would provide some benefit for the AI learning to, in a sense, imitate the expert. So what is the state of imitation learning? Like right now, the AI field is being consumed by large language models, and from what I could see of the state of the art of imitation learning is that in general, this is not a very good way to do most things. Like there are probably some things that I've missed, and probably someone who's really into this can say, but in general, this is not the way things are moving. And it's of course an interesting question. Like right now, for many tasks, GPT 4 are close to a human expert level, and GPT 5, 6, or something like that, probably is going to reach a human expert level. And but I care most about the strategic domains. And the question is, will GPT 6 be able to reach the human expert level, or will something like imitation learning be required? I think GPT like the trajectory we're on is really strongly favoring large language models, and I think this is a reasonably broadly shared consensus that imitation learning is not really the thing right now. And there are of course good reasons for this. We don't actually want something that is what a human would do. We don't really want imitation of the human. We want the best answers. We want something that maximizes capability. We don't want like code with human-like errors. We want actually right code, right? So there might of course be a different reason to build something that is more human-like, and that would be to that it may have some properties that make it more safe, and that is a good reason to build something like imitation learning. In that case, of course, we need to think about something that will be deployed with much more intelligence and much better algorithms and much more compute than we already have. And to Michael Cohen's credit, in this paper, in the introduction, it is made quite clear that we are talking about sufficiently advanced imitation learning. And as I see it, we are like, if we choose this for safety reasons, then the only reason we would do this is because we expect it to retain the safety properties even as we get to a dramatically more competent level, potential superintelligence, potential much faster computers, etc. Unfortunately, the question of whether imitation learning is safe is something that is hard to find out, and I think that I would call the debate broken. And let me try to state why I think this debate is broken. So, imitation learning is in general a field that, as far as I can see it, only cares about capability, or almost exclusively cares about capabilities. There are some safety properties like self-driving cars not killing people and things like that, but no existential safety. And that's of course like we want to get up to the human expert level. And that means that there appear to be no formal rigorous text that argues that yes, imitation learning is existentially safe. I tried to use Google to see whether someone had written anything on this. The best I could find was like literally this paper. It's the top result in Google, but this is the kind of thing I may be wrong on. The thing that makes this broken is that AI safety researchers look at imitation learning and think this is obviously not safe, and because there are no rigorous arguments that they can answer, then they instead make some vague, disjointed, and like unrigorous arguments against instrumental learning. And this is the state of things where Michael Cohen, he looks at these arguments and say they are really poorly thought out. He has a problem at this point, however, because while the arguments may be poor in like as arguments, they are also written up really, really badly, and that makes it very hard for Michael Cohen to write his counter arguments. I think like the obvious correct solution in a perfect world would be to like write a long, very, very serious text that makes precisely the case in all detail that imitation learning is existentially safe. That's a lot of work, and getting feedback on this is a lot of work. Like I think also it's impossible to write this document. So like it's easy for me to make this statement. Let me try to talk a bit about whether I think imitation learning is safe before we actually really dive into the paper. So the claim from the title is that imitation learning is probably existentially safe. And I would ask, what evidence does Michael Cohen and Marcus Hutter bring to bear to this? And they make a very, very simple argument and answer 6 objections. And I think this is very strongly insufficient. You would totally not design a nuclear reactor based on something like this. I share the intuition that answering objection is actually the key thing to do, but I think this needs to be done in a much more systematic investigation in order to say anything about whether imitation learning is existentially safe. I think a couple of key pieces that have shaped my thoughts on this subject is Stuart Armstrong's work on sub-agents and Nick Bostrom's work on tool agents, which I also feel has a substantial overlap. So my recommendation would look into this, but that is of course that is Michael Cohen. Yeah, I don't have a good way to argue whether imitation learning is safe or not. However, I want to highlight a different argument that may be original to me, maybe other people have also made it. But one problem with, instead of just maximizing capability, like most reinforcement learning, is then once you have a goal of the AI, or something like some reference to humans, then a maximizing failure could be a very bad thing. In particular, some kind of suffering risk, in the sense that if you have an AI and you are asked to, if you have a human and you ask a human to write a blog post, then that is something that human experts could write something that is beautiful and complex and have a lot of value, and it's also really, really difficult, because how do you predict that Scott Alexander, based on like if you ask him to write a blog, that he will write this particular blog? That's an enormously difficult prediction task. Whereas if you change the input to him, like what happens when Scott Alexander stubs his toes, well, then I think the answer is probably he will just say ow. And that's a much simpler situation. So we really want to avoid a situation where we end up maximizing ease of imitation. Now let's get into the actual paper. Michael Cohen starts by presenting a simple argument for the safety of imitation learning. The first premise is that no human have ever gained total control over humanity. It's obviously true, but it is not true that no human has ever tried. In fact, a lot of humans have tried, and once we start to get towards power seeking, that's a thing that humans do literally all the time. Or not literally all the time, but a lot. The second premise is that very few humans would accept human extinction. I think this is in general also right, but a big thing should be noted here, that some people do in fact accept this, and people like effective accelerationism, who often to very extent accept this, are also the kind of people who are building these systems. So if the people who are actually building this and the experts that they're imitating are people who would accept human extinction, then this argument does in fact not carry. And the conclusion from these premises is that a just barely competent human imitator would not do this. I think this is like more a general thing with this paper, where very often it talks about like this minimally competent imitator, and I think this presents the wrong intuition. Like, we are talking about something that scales really far, and that means that the imitator is not making very basic mistakes. The imitator should be supposed to have extreme amounts of compute and a super intelligence in practice. My real counter-argument to this is that there are a number of ways this could fail, where a human imitator might do the same thing as a human, and if you make a Sam Altman imitator, then you'll end up creating AGI, a super intelligence that is not a human imitator, and that would kill us. Like, that's an obvious failure mode. A lot of humans want to make more of themselves, and the people who build these human imitators probably also want to make more of them. That could lead to easy ecological devastation and more luck and things like that. A third problem is that a lot of humans really like to kill other humans, in particular humans that are different from themselves in some way. Right now, it seems that if someone is like, if something that is not running on the same substrate as of us, like silicon instead of carbon, then people in general find it totally acceptable to kill them. Like we turn computer programs off without a second thought, and that is in fact something that we really would not like to imitate. And then there are many other ways that human imitation could be not existentially safe. You could have misuse, you don't get a pivotal act, you could have tyranny. There's all these kind of things that this paper doesn't even try to answer. And I think if you want to make a strong, rigorous argument for the safety of imitation learning, then you need to consider these kind of points. Let's get to the arguments, and the first is the attention director argument by Elias Yudkowsky back from 2008. And when I read this, I was like, wow, what is this? I have in fact read the sequences, and I don't remember an attention director argument. And I looked at the reference, and I thought, wait, there is something really wrong here. Are the references in fact broken? Because the paper says that here is Yudkowsky's 2008 attention director argument, and then it presents it, and there is of course a reference for this, points to this URL, and if you go there, I should say Marcus Hutter does in fact state that the original text is no thorougher than what is here, so this may be like written with more details and things like that, and when I looked at this, I was just like, it is totally not there. It is there is nothing that looks even remotely like this in this reference. Then I looked at it some more, and I did in fact find it verbatim somewhere else in a Twitter thread that was referenced in chapter 6, which we'll also read. And this is the link to the Twitter thread, and it contains this precise argument, but even though the paper describes this as Yudkowsky's argument, then on the Twitter thread you can see that this is written by Michael Cohen, not Elias Yudkowsky. So that was like kind of a strange thing, and like in general I totally forgive Michael Cohen for this, because the original arguments were written down in a really poor way, and I think he does a good job at writing them up in an honest, sympathetic, basically what we call steel manning. So I think this is part of what I mean with the debate being broken, that he has to do this work to actually get the arguments, and that should be a thing that Elias Yudkowsky should have done. Right, let's have a look at the attention director argument for on safety. So you imagine that there is this is the human that we're imitating, and there is this devil on his shoulder that is whispering and pointing towards things where the human should direct his attention. And so learned imitation is a prediction of what actions a human would take. That seems reasonable enough. Really high quality predictions sometimes requires making decisions about where to direct attention. I think this is you could charm this a lot more. Like, it's not really high quality, and it's not only sometimes. You always need to make decisions about where to direct attentions. So if you make these kind of choices, then you need some kind of goal, and the goal would be to come up with an accurate prediction. I think this argument needs to be strengthened a bit, so I've added clause 3.5 here. And my clause 3.5 is that the human imitation AI may want to create a sub-agent for this part of the task of figuring out where to direct attention, and let's call that a goal-oriented attention director. Now, it seems in general most goals are best accomplished by a takeover, taking over the world and directing all resources towards it, and this goal-oriented attention director that was created for this subtask will recognize this is true, and then it will do so. I'm not really sure that attention director really cuts reality at the joint, and it's not something that really is in the source at all. I think like you could have many other potential sub-agents, like having one that has a goal of having an accurate world model and things like that. I think the prediction to my view, is like the central part of like the most important sub-agent in this learned imitation. So, short-term or long-term goals? Well, if this attention directed, if the attention director, the goal-oriented attention director, has the task of making a prediction, well, that's a short-term problem, and directing your attention somewhere, that's an even more short-term problem. Whereas taking over the world is something that probably requires more than like 1 second of CPU time. And that means that if your task is to make a good prediction and nothing else after that, then taking over the world is probably not the best option. That seems quite likely. I'm not entirely sure this argument carries, because we're not talking about something that imitates a human, but an imitation learner. So there is some kind of focus on, so it's not a human imitation maximizer, but an imitation learner. It will learn during training, of course, and that may be safe or unsafe. Will it also learn while being deployed? Well, probably. In general, we prefer that our AI algorithms learn as much as possible. That's a nice thing. And if it's also learning while it is deployed, then it doesn't want to minimize the error of a single prediction, but minimizing the errors summed in some way of all its predictions. And if it's trying to do that, then that is in fact a long-term effort. If it's all predictions, then it's potentially totally unbounded. And in that case, taking over the world is probably the thing that gives it the lowest, the best predictions over a very long time horizon.
I'm not really. Sorry, can I comment here? I'm not so sure that's true.
Mm-hmm.
I mean, from like, what would make you think that it's? I mean, gradient descent algorithms are greedy by their very nature. So, they every time there's a difference between their current prediction, between reality and their current prediction, there's like back propagation to make sure that the structures responsible for producing that result are downregulated, and the counterfactual networks that would have resulted in a more accurate result to be upregulated. Sorry,
Mm-hmm.
that's a very weird terminology. I'm tired. Anyways, the thing is like if a yeah if a um an agent that's trained by gradient descent can take an option, can take an action that results in it having a slightly higher loss now, but a much lower loss in the future, like that would still be penalized because like the structures that lead it to having those thoughts and taking that action would still be penalized because you can't like I remember there was this really good article on Less Wrong about like how you can't make future trades with gradient descent. It always maximizes like minimizes the error in a very greedy kind of way.
Mm-hmm.
Um, what is your opinion about that?
So I would very much like a link to that, because I think that is something that may come up a lot more next time. In this case, if you are looking at a very large number of predictions and also future predictions, no, actually I would make a simpler argument, and that is that you don't know that it's using gradient descent. It could be using something very different. It could be using a good old-fashioned AI with a utility function. Like we're not making any assumptions about the structure of the sub-agent, and let's assume that we're back in 2005, and the way we're doing this is that we're writing a utility where it is minimizing the error of the prediction today and the predictions tomorrow and the predictions 10 days ahead. And if we're doing that, then I think it is very clear that we are looking at a long-term effect. I think it is probably possible. a bit uncertain about how you would minimize the errors of future predictions with gradient descent. So I think I would need to have that specified in a bit more details before I could comment on that. My point is just that there are certainly ways to implement this that makes this predictor a very long-term agent. Do you think that's fair to say?
I mean, I think we're past spherical cows at this point. I mean, my assumption going into the discussion is that we were talking about using we're going to discuss the properties of imitation agents that might actually become AGI or ASI that we might see in the near future. So which I assume would involve gradient descent algorithms, and we try to say, okay, given the current architectures and given what we know about them, what would an imitation learner that's actually built in the next 5 years, that's actually an AGI, what would be its properties? Can we prove it to be safe? Yeah, that. What do you think?
I think that would be an interesting way to probably make this problem a lot more tractable. To try to see if we, instead of just saying a general imitation learner, then saying an imitation learner that is based on gradient descent is probably existentially safe. That would be a simpler argument, and I think it may be a lot easier to make that argument carry compared to the argument that Michael Cohen is making here, where it's just based on the fact that it's imitation learning and not knowing very much about the algorithms below.
Huh. Okay.
Cool. I think this is a question here that Michael Cohen suggests is: will there be a sub-agent that has some properties about what it's thinking about and whether it's doing something long term? Well, it probably would not do that if that didn't have any influence on whether it directed attention in the right way. And so if it doesn't help it direct attention, then it will not have long-term state. I think that is probably true, but I also think that reuse of attention seems like something that is almost certainly going to be useful. You imagine that you have a human imitator that is answering a question, and then the human imitator says I don't know, quotes Hamlet or something, quotes Shakespeare, and then there's half a sentence output with half a quote by Shakespeare, and then the next thing that the human imitator should do is finish the quote by Shakespeare. In that case, the attention structure that has brought it towards Shakespeare seems like something that could be reused in a very strong way. There's no way, if you have thought long and hard about whether the correct thing is to quote Shakespeare at this point, then you may as well keep that information for just a little while at least. So I think in general, starting over totally from scratch seem like something that will be selected against, will not perform. So I think this is a part where I feel Michael Cohen is not very clear to what extent does the sub-agent have this kind of long-term state. And I think what Michael Cohen is arguing is that it will not have any kind of long-term state. And I think if we make the assumption that these sub-agents have a very long time state, then the argument just purely doesn't work. But it's a bit unclear, and I would like some clarification on this point. So what I'm going to do from here is to assume that it's possible to make this sub-agent direct attention in a way that doesn't depend on any kind of long-term state. So let's go into the actual counter-arguments. The first counter-argument is that if we make a goal-directed agent, and this is a goal-directed attention director, then it must have some beliefs about the consequences of their actions. And I think that's true. And I also note here that Cohen just grants that there will be a sub-agent, because it's certainly possible to build AIs that don't have explicit sub-agents. But I think he does the right thing in making this kind of worst-case assumptions. The second thing, if the sub-agent have like two models of what are the consequences of its past behavior, well, and one of them is simple and another one is more complex, then probably, like, why should it have a complex model? It could just use the simple model. That's Occam's razor. This is what I think is one of my key objections to the arguments, in that if the sub-agents has to choose between two models that are somewhat different, then we should remember that it's a superintelligence. And if a superintelligence is choosing between two models, then probably whether one is simpler than the other isn't really the important thing. The superintelligence is just straight up likely to choose the correct model. And I think that is a very important point. I'm also not sure that Occam's razor really applies in this. This is like, I'm not a scholar of this, and I think Marcus Hutter probably knows way more about this than I do. So this isn't like really my objection to this. I just want to point out that this is extremely brittle, because if you have two models of your past behavior and you just get a tiny bit of evidence on that the more complex model is true, then this totally collapses in general. And I think that it is very easy to get a tiny bit of evidence for something that is in fact true. So let's look at a simple and a complex world model. The sub-agent could have two different models of the effects of its action. First is that it's in some kind of theoretical computational environment where there are no effects, there are no side effects, there are no effects after the computation is finished. Everything is running on like theoretical perfect computers. That's model N. And then there's a model M, which is the thing that is actually happening. That there is in fact a computer that is using a CPU that gets hot and takes time, and it's located somewhere on the planet Earth, and it has side effects and all these kind of things. And let's call that model M. I think the two names N and M are really badly chosen. Maybe you could choose something a bit better. One of the things that is required for this argument to carry is that the theoretical simple model must be in fact substantially simpler than the model M, the true model. Michael Cohen argues that this is in fact non-trivial, because even the simple world model needs to include the sub-agent, but it doesn't only include the actual actions and the sub-action, the counterfactuals. I'm not really sure I understand that. I think just straight up side channels is the thing that convinced me that model M is in fact substantially more complex, because that's totally a thing that is in the model M that is not in the model N, so it is probably more complex. I accept that model N is simplified. Let's try to draw that. This is the actual state. There is a planet called Earth where there is a computer running that makes some choice about where to direct attention, and then this computer also have a model of the world and makes a prediction, and there are side channels, and that's how it's actually. Now the simplified model distinguishes, it has no side effects, and it distinguishes between the model of the world and the actual world, and then these two are then compared and to give some kind of predictive accuracy, whereas in model M, the thing that I call real, then there are side channels, and it's running on the actual planet Earth. The last part of the argument is that the simple model N, is in fact sufficient. So the argument goes that if the sub-agent hasn't seen any effects of its actions that can't be explained by the simple computational environment, that means that it can just use the simple model for understanding what has happened in the past. And I think here we need to like really distinguish between like how right was I when I said that Michael Cohen assumes that the sub-agent doesn't have state from prediction to prediction. Because if there is no state at all, then I think this is trivially true. It will never before have seen a thing because like it doesn't have state, and if it does have state, if it does remember what has previously happened, then I think the statement is just straight up false, because there are a couple of things it must have seen. One of them would be the time taken to reach a prediction. Like if the goal-directed attention director uses 10 seconds or use 1 second, well, from the point of view of a human interacting with a human imitating model, like if it takes 10 seconds to give an answer, we will say, oh, that's a really poor, because it's so slow, and like it matters a lot, and matters obviously. And also, like, how good is the prediction? If you predict that the imitation learner will, say something that a human would not say, if you make bad predictions, then that also has obvious effects. So there will be some kind of effects by the actions of both the predictor and the attention director. So for this simple model, if it's viable, and then it will probably start with the hypothesis that it's running on some kind of perfect computer. So it doesn't see like bits getting flipped by cosmic radiation or something like that, because that happens very rarely. Computers are very robust in that. So it probably will not encounter evidence against this simple hypothesis. And that means that this sub-agent will never understand that its actions affect the outside world in any way. And I must just say, this is a really, really stupid superintelligence. Huh? It's something that is totally obvious to humans. Like, why would a superintelligence be unable to figure this out? And I think that is like the core of my arguments, that you can't deceive a superintelligence with in such a simple way. The next argument in chapter 6 is the rational subroutine argument by Yudkowsky in 2023. And this is an argument that if we are building a human imitator, there will be this rational subroutine inside it that will potentially come out and give problems. So if we assume that, like, humans can do means-end reasoning, so if you have an imitator that's imitating a human, then this imitator would also be able to do it. There must be something inside that can do that. And if you have a subroutine that can do means-end reasoning, well, it will likely discover that the best way to achieve its end doing means-end reasoning is to gain control over humans, so it will. And that's, of course, a very simplified argument, like just this "so it will" is a kind of cavalier way of referencing the entire sub-agent problem. So let's talk about means-end reasoning. So this is an obvious simplified example. You have an initial state, and then you do some actions to get to this kind of goal state. But actually, there are several ways to do that. There is the way humans do means-end reasoning, and there is the optimal way of doing means-end reasoning. Humans are not really optimized. Humans get a bit lazy, but they generally do pretty well at means-end reasoning. Optimal means-end reasoning, that's the kind of where we have theory, where you use all the resources in the light cone and turn everything into computronium and freeze the universe for 1 trillion years to these kind of things. These are in fact potentially quite different. And why would, if you're trying to imitate human means-end reasoning, why would you do something that has anything to do with optimal means-end reasoning? That's a thing that requires justification. And I agree, it does in fact require justification. And there are several ways this could happen. One example would be instrumental convergence. In the many things that the optimal means-end reasoner would do are also things that humans would do. Self-preservation would be a thing, and all the other instrumental drives are things that probably humans would also do. So you could infer from the optimal means-end reasoning and get a decent idea about what humans would do. You could also say, the best way to model human means-end reasoning is to just have optimal means-end reasoning plus some errors, plus some irrationality or something like that. Or a third alternative that I just thought of is that you actually don't need to bring in a lot of this, because humans are obviously capable of doing enough means-end reasoning to realize that they should take over the universe. because like humans can figure this out because like we are humans and we figured it out. So a problem with this is that just because you have something that can do means-end reasoning doesn't mean that it will actually follow the plan. I think there is an error in the second last line of this part of the paper, where I think Michael Cohen means output instead of input. It's of course also a possibility that I've totally misunderstood, so beware. The means-end reasoning has as an input some goals and action space and beliefs, and as output it outputs a set of actions. But the means-end reasoner doesn't actually do the actions. This seems like something that would hold it back from doing it. But I guess if it's like a mean-end subroutine, then it could just do it. It would figure that out. That's the right way to do things. That's not very difficult. Well, no. Michael Cohen argues that the means-end reasoning subroutine exists because of the need to imitate human means-end reasoning and taking actions. That's not a thing that helps imitating human means-end reasoning. And it's true, it doesn't do that. We need to have the entire sub-agent problem for this agent to argument to work. So let's assume instead that we have a means-end reasoner, and this means-end reasoner is like it has an objective. Let's say it's like a paperclip. It has an objective function that is to do the perfect means-end reasoning, and it's also super intelligent. And it's measured means-end reasoning in some way by like you can measure this in many different ways, and all of them are probably best done by taking control of the entire universe and turning everything to computronium, etc. And this is a different. It doesn't help with the goal that the entire system have of imitating human means-end reasoning. It just helps with doing means-end reasoning, and that's why the sub-agent would take over for the entire structure, and they later take over the entire universe. The third is chapter argument and last argument we'll look at today is Brandman's. It looks like you're trying to take over the world, and he doesn't say this is a very likely hypothetical, but plausible enough to discuss. And Michael Cohen calls this the character destiny argument. And one thing that I would like to really highlight here is that there is in fact no learned human imitator in this story at all. And you could kind of perhaps make a parallel story that features a learned human imitator, but it is the story is totally not about that. And that means that this argument is it's really not a coherent argument against learned human imitator. But let's try to adapt it. So in this case, we have a learned imitator that is trained to imitate human text, and then for some reason it comes to believe that its past actions are those of an origin story of a super intelligent AI. So that's kind of what Gwen is going for, and this is something that Michael Cohen thinks is really unlikely, but you could try to deliberately have that happen. So this is like the thing people are doing with Chaos GPT. They're trying to do this deliberately, and like you don't get safety against that. And I accept totally that. Yeah, imitation learning. I would be willing to say that imitation learning is existentially safe as long as you don't actually use it for Chaos GPT. Then, like no algorithm. Does that make sense? Is that
like you're saying that imitation learning is safe across any possible implementation of artificial intelligence as long as you don't implement something, as long as you don't specifically ask it to destroy the world?
The argument that I'm making is that if someone claimed that imitation learning is existentially safe, then I would consider that a true statement, even if there was written down in the text with small letters that it is in fact not existentially safe if you very deliberately ask a human imitator to destroy the world. I would still think that it is of course, dramatically better than we have right now, to the point where I would grant the statement that it is existentially safe as long as you don't like try to deliberately destroy the world. So I don't like. I think this is not something that has to happen. That it's not that unlikely. There is the Valuigi effect as something that seems to point towards this being a thing that could happen potentially. I haven't looked too much into it, but let's say that the you have a an imitator that has a text that describes its past actions, and you have two hypotheses for this text. The first is that they are from a story about a super intelligence that is eventually going to take over, or it's a story that a human has written, and this is like just a novel or something like that. Which of these two are more likely? Well, we need to remember that the actions that the AI remembers is that I just did some self-improvement while doing some self-supervised training. So this is the kind of thing that fits quite poorly into a novel. I think like if you look at the logs of AIs doing self-supervised training, it totally does not look like a novel. But of these two hypotheses, the claim from Michael Cohen is that the AI will believe the second because it is the truth, and I'm like confused because it's not really the truth at all. Like it's not a human that has written this down in Gwern's story. It is like thinks that it is in fact an AI that is doing self-improvement in self-supervised training. So it is none of these things, but I think it is in fact closer to the story about the superintelligence than a novel, or it could potentially be that. And in this case, the AI would choose that. And the result of this character destiny would be a takeover, because the AI is predicting that the continuation of the story that starts with an AI self-improving is one where the AI takes control and causes human extinction, and so it does that. Well, it does in this story, but if it was not something that I think in Gwern's story, it is very strongly not something that is trying to imitate humans. But if it was at this point something that was trying to imitate humans, well, then it couldn't do that, because humans can't take over the world. So if you're imitating a human, you won't be able to take over the world. I think like depending on the intelligence level, this may and may not be true. In particular, if we choose to implement human imitators because like for safety reasons, then we may be very, very vulnerable. It may, for instance, be that this like if we're in a situation where like there are trillions of robots deployed in the world that is all running the same software or something like that. If we do something like that, then even in a very poorly written story, it seems like the balance of power is just extremely lopsided towards the AI. So it would in effect be possible even with a badly written story to take over the world.
There's a couple things I want to bring up here. First of all, is that my general vibe from Gwern and the story is that he knows it's full of like plot holes, and that this is like for this to actually happen is very unlikely, but it makes for a good and engaging story, and it's like kind of food for thought. It's like, oh, that's an interesting idea. In theory, an AI might go rogue because of this specifically, and it's like interesting and goofy and like kind of funny, but like it doesn't seem like he's saying this is an actually plausible series of events that leads to an AI takeover. Well, no, it's not. He's not saying that this is the most likely sequence of events that leads to an AI takeover. It's just like good narrative.
I strongly agree. Yes.
And the other thing is that like single human beings have come relatively close to taking over the entire world. Like if you made Mao Zedong like immortal and able to think billions of times faster than human and smarter than von Neumann and having you know, social skills that are as good as von Neumann's physics skills, I'd say he probably would have taken over the world. Yeah.
So this is like a general intuition discussion that I'd like to go in, but I'd like to just wrap up the video and then we can talk about it.
Okay. Yeah. Of course.
So, well, I think basically it. Thank you for watching and see you next time.